Yeah, I fixed today's though. All right, 2-1, day 2. Two learning targets today.
Like, drawn back in a little bit more. Yeah?
Can you sing the Greek alphabet?
I cannot. Okay, to know the values on the sides of the 45, 45, 90 triangle and the 30, 60, 90 triangle. We spent a lot of time on this in geometry, knowing that relationship, so we're going to bring that back to the front of the brain. And then your second learning target is to use those triangles use the triangles to find the exact trig ratios for 30, 60, and 45 degree angles. Yeah.
Why do we have learning targets?
It's our school goal to improve SAT scores. If we tell you what you need to know at the start of the lesson, hopefully you are paying attention all the way through and saying, yes, I figured those things out. So, I mean, we never wrote them down before. Back when, if you ever go into education teaching, the very first thing they had you do was make a lesson objective. What do you want the kids to know when you're done? Okay, so yeah, every lesson plan we ever wrote as teachers, you always had your objective. What do you want the kids to know when you're done? Now they're just saying, pretty much take that objective, tell them what you want them to know at the end. So if you tell them what they want them to know, maybe they'll pick up on it. So we'll see. We're going to give it a whirl. It can't hurt. We are going to do that too. It's coming. Trust me. All right, so let's review that very first special rate triangle, the 45, 45, 90. Oops, 45, 45, 90. Do you remember what shape we started with to create the 45, 45, 90? It was a square that we started with. Okay, what do we know about the sides on a square? They are equal. All these sides are the same. Okay? So we say, and they're 90 degree angles in the corner. When we draw in the diagonal, we create that very special right triangle. We create the 45, 45 right triangle. Do you remember the shortcut to get from the legs to the hypotenuse? Everett? It is not 2 square root of 3. But try though. It has a square root in it. Let's do one and see.
2x.
You just have a poster.
Yeah.
I did. Yeah, if you were in my geometry class, your eyes probably went right over there to look, because we looked at it all year. But we're not there yet. And it's not for trig, it's for geometry.
You need them though.
Yeah, please.
Nope, you're going to have them in your notes.
Hard to remember.
All right, we're going to put 3's. We're going to do one, and then you're going to find the shortcut.
I know the shortcut.
Okay?
Square root.
He says square root of 3.
No, I know.
Oh, he's going to change his mind now. Okay, so Pythagoras, and we'll find this side length.
Square root of x.
3 squared plus 3 squared equals x squared. 9 plus 9 is 18. So we do the square root of 18. How does that simplify? What's in 18 that's a square number that we can take out? 9 comes out as So we have 3 times the square root of 2. So what did this leg length of 3 get multiplied by? A square root of 2. So, our ratio, or the, ratio I guess, if you have a 45, 45, 90, the 2 legs will be the same, and the shortcut to get to the hypotenuse is take that leg length and multiply it by a square root of 2. You remember this a little bit? Now that we know it, now that we wrote it down.
There's another way you divide by.
If I start here, we got to go backwards. Yeah, we're doing that right now. So example 1, now that we know the ratio of the sides, 1 to 1 to square root of 2, we're going to find the missing sides. Alright, so the tick marks make it a 45, 45. If I give you a 7, can you fill in the other 2 sides?
Yes, 1 is 7.
One of them 7. Hopefully this one down here. What's the hypotenuse going to be? 7 times the square root of 2. Doesn't get much harder, does it? Easier. I should say, it doesn't get much easier than that. I don't care. I want all exact values. No decimals allowed.
What is it? What is it? 7.3 now. No, I know, but I'm guessing you don't want to use it.
Let me challenge you. Let me give you
This was there.
3 square root of 6 on a side length.
Oh, no. Not this one. Well,
Alright.
I know one. Short.
Which one do you know?
I know the one.
The one with the tick mark on it?
Yes, it is 3 square root.
It is 3 square root of 6. Okay. So the process doesn't change though. Even though this is ugly, what did we do to get from the leg to the hypotenuse? Multiply by a square root of 2. So we would have 3 square root of 6 multiplied by a square root of 2. Well, what's allowed to multiply in that business? The square root. So we would have 3 square root of 12. Does the square root of 12 simplify?
Oh, yeah.
Unfortunately, yeah. So we got a little more work to do. What happens here with the square root of 12? That's 4 and 3. So what does the square root of 4 turn into? A 2. That comes out as a 2. Multiplied by the 3 that's out there. Can I do it in baby steps so I don't lose anybody? So the square root of 12 turns into 2 square root of 3. The 3 and 2 multiply and you get 6 square root of 3.
Oh, so anytime you have anything.
So I did baby steps, so hopefully nobody got lost there.
Which works?
Yes.
You know, like, well, this class, your class,
What?
I can just talk out loud.
Oh, okay. Well, I'm glad.
Because it helps me, because if I just say it out loud,
Yeah.
then I just know it.
Okay, that's good. I'm not opposed to that.
You would probably not like it if I was just talking.
No, probably not.
You didn't like many things.
True.
All right. 2 left here. Still a 45, 45. I'm going to give you the hypotenuse. So, you have to do the opposite. If we know the leg, we multiply to get to this hypotenuse. So we do the opposite to get back. What do we divide by? The square root of 2. So this leg will be 10 divided by the square root of 2. The only problem is we can't leave the square root in the bottom. Hit it with a 1. Hit it. Make it cry. So we will have 10 times the square root of 2 over 2. Anything simplify? 10 and the 2. We get 5 square root of 2. And now what's the other leg? 5 square root of 2. And then the last one, the hardest I can make this, I've covered everything, is to put something ugly on that hypotenuse.
I was just gonna say that,
This is exactly the same thing we did there. Give you hypotenuse again, but it's going to be 4 square root of 3. Ugly, but I don't care. What's the process if you know the hypotenuse and you want to come backwards? What?
Hello?
We're dividing by square root of 2? And then the one that bothers us, the one that's not allowed, is the square root in the bottom. The one at the top's fine, so we hit it with a 1. So we get 4 square root of 6 over 2. And the 2 and the 4 are reduced again. 2 square root of 6, so then 2 square root of 6. Okay, so we've got the 45, 45. Legs are equal. Times by square root of 2 to get the hypotenuse, divide to get off. Back to the leg. Alright, the other special triangle. Number 2. They're very special. It's our 30, 60, 90. This one's created when we take the equilateral triangle and make 2 right triangles out of it. So equilateral. 3 sides are congruent, and we have 3 60-degree angles. Okay, so all 3 sides are the same length. Now, making the right triangle. We just drop from the top vertex straight down. Now we have got a 90. We've cut the 60 in half to a 30. Bad 30. 30. Okay. This side was our original side length on our triangle. How does this side compare to this bottom short leg here? It is half.
I mean, it's double. That's double that.
That's double that, or this is half of that. So if I call this x, I call this one half x. It's not the way we had it in the poster. 'Cause
We should do like the poster.
we are going to do it like the poster, but that's the relationship. So let's go back to the poster, because it is our shortest leg, our shortest side. So we'll call that 1x, and then we know that that hypotenuse is double it because of the relationship here. So we'll call this 2x. Do you remember the multiplier to get to the long leg? It was square root of 3. You take that short leg
21.
times square root of 3. So short leg is considered a 1, hypotenuse a 2, and then square root of 3. So see, 1, 2, square root of 3. 1, 2, square root of 3. Okay, let's practice me giving you one part, you finding the other 2. Here we go. Start easy. I'll make it ugly though. I'm going to give you the short leg and I'm going to make it 5 square root of 2. Just because I can. That, well, I got to make a 30. 30, 60, 90 for sure. You got to know it's a 30, 60, 90. With the tick marks on the 45, 45, that automatically make it at 45. They didn't have to write them in, but now this time I do have to write the 30 and 60 in. Okay, here's the short leg. Short leg. Hypotenuse is always double the short leg. So if I double this, what's that going to give me? 10 square root of 2. Okay? Now how do I get from the, always go back to the short leg to long leg. Short leg to long leg is multiplied by?
Square root of 3.
Square root of 3. So we got 5 square root of 2 multiplied by a square root of 3. Combine, and what do you have? 5 square root of 6.
Bullseye.
Okay. Starting from the short leg is easy. You multiply by 2, you multiply by square root of 3. If we don't start with the short leg, then you got to start with the division. let me give you,
I love math. Seriously.
looks like I gave Haas long leg.
I want to do math for the rest of my life.
Long leg.
I'm not kidding.
Okay, actuary is your goal.
Is it?
Yep,
Okay.
all I do is math all day long.
Is it easy math?
Nope.
Cool. Yeah, yeah.
Okay, I have the long leg. I have the long leg. Remember, I was multiplied by the square root of 3 if I was the short leg. So if I multiply by square root of 3 to get to the long leg, how do I get back to the short leg? Divide by square root of 3. If you multiply to get here, you divide to get back. So I take this and I divide by square root of 3 to get the short leg. And we just got to hit it with a 1.
So that'd be 8 square root of 3 over
8 square root of 3 over 3. Now that we've got the short leg, how do I multiply to get to the hypotenuse? By 2. It's always short leg. We always find the short leg first, then we move from the short leg. So it's always short leg to each of those. Find short leg first. So short leg is 8 square root of 3 over 3. You got to times by 2. That will give us 16 square root of 3 over 3.
I always feel like
And our last one of these, let's see, we got to start with the hypotenuse this time.
So let's see where we are at on learning targets.
Yeah. 3.
Hey, according to learning targets, this is all we're doing.
No, what was the second one?
trig ratios.
Trig ratios. Okay. So if we have the hypotenuse, what do you do first, and what will you be finding? Divide by 2 to find the short leg, the x. So I have the hypotenuse. I can see it's been multiplied by 2, so I got to divide by 2 to get back to the short leg. So that'll be 3 square root of 5, divide by 2. And that's a good answer. There's nothing wrong with it. Now what do you do to short leg to get to long leg? What's the multiplier there? Square root of 3. So we keep that. 3 square root of 5 over 2 times by a square root of 3. That'll give us 3 square root of 15 over 2. You can do that. That was all, we did all that in geometry. Now, learning target 2 is to find the trig values for 30, 45, and 60.
What about for, never mind.
Just those 3, 30, 45, and 60.
No, I was thinking, never mind.
Okay.
You like another one? But you know, all this is
Oh, I knew stuff was going to fly.
oh, so much material.
Okay. I need, of course, I need this paper that blew away. Let's go with the 45-degree angle first.
Did you decide you wanted to be a pool or did those things happen? No, I decided that.
Okay, if we're going to find trig values, we need triangles. So half the class is going to work with, if I look back on the first set of notes, where are you? Right here. We did, I'm going to look back at these 2 triangles. Well, maybe this one I'm going to go with. Seven, 7, and 7 square root of 2. Then the other triangle, the other half of the class, we're going to go with, I don't want that one, it's too ugly. I'm going to make up another one. I'm going to go with 10, 10, and 10 square root of 2. So technically the triangles are different sizes, but they're both 45, 45, 90s. Agree?
I agree.
Okay. 45-degree angle right here. 45-degree angle right here. Okay, we'll have these first two rows here. You guys are going to do sine of 45 degree off of this triangle. The rest of the class, you're going to do the same 6, but you're going to stand over here and do sine, cosine, tangent from standing on the 45-degree angle. So go ahead, fill them in. Remember what? Think SOHCAHTOA.
Oh.
SOHCAHTOA. And you only have to do one column on this. I'm going to do both, but you only need one on your notes. Compare with someone if you want to compare. Make sure you're doing it right.
Yes. Very peculiar.
So use your SOHCAHTOA ratios. Reduce down. Huh? You forget SOHCAHTOA?
First law of right
What's that, Daniel? 1 over 1 is 21.1. Oh. Oh no.
Was that enough time or not quite?
I mean, color-wise. $100, Dan, buy the snowmobile.
Your stuff?
If it runs, buy it.
If it runs. Do you get a running snowmobile for $100? I'm not thinking you do.
No. Buy Christian's like for $100.
So the one that breaks.
Are we good?
$100 you want.
Carson, did you struggle with this?
No, I'm just trying to remember.
Still trying to remember. All right, Caitlin, tell me what you had for sine, please. It's all the way simplified out. What did you get?
I did the other one.
Oh, you did this one over here.
Yeah.
Oh, well.
Okay.
Gosh, you did the other one. Reese, what do you got? You got radical 2 over 2. I like that. Keep going, Reese. Radical 2 over 2. Tangent? 1. Cosecant? Secant? And cotangent? All right, since you did the other triangle. Caitlin, what did you get?
Radical 2 over 2.
I like that.
Radical 2 over 2.
Yep.
1.
1.
The radical 2.
It is.
Radical 2.
Did you do that on purpose?
Yes, to prove a point.
They're all the same.
If you're standing on a 45-degree angle, it does not matter how small or large the triangle is. Both legs will always be equal, and the hypotenuse will always be whatever that leg is times the square root of 2. So when you reduce down, you always will get the same ratio. So it doesn't matter when we ask for the sine of 45, no matter what triangle we draw, when we set up opposite over hypotenuse, we are always going to reduce down to this value.
That's literally all we need to know.
That's really all you needed to know.
That was a theorem discovery.
That was a theorem discovery.
Minus the theorem.
Okay.
Mrs. Schwartz.
I am going to give you a handy-dandy shortcut to this to come up with these so you don't have to draw the triangles all the time. But for now, we're going to stick with the triangles. So, let's do the 30-degree angle. Doing the exact trig values. Okay. Example 4. 30 degrees. So all we need is a 30, 60, 90 triangle. It doesn't matter how big we make the sides as long as that relationship is there where we got the 1, the 2, and the square root of 3. We agree with that? It does not matter? So we just make up any 30, 60, 90 we want. Okay. The 30 will always be across from the shorter leg. You remember that from geometry? Okay. What number? You get to pick. Pick the short leg to be anything you want. Smaller is going to be better because you don't have to do all the reducing. 1 would be best. If that's 1, then what is your hypotenuse going to be?
Square root of 3.
2. And then what will the long leg be?
Square root of 3.
Square root of 3.
Square root of 3 is less.
Correct. That 1, 2, square root of 3. So you just got to get them on the right spot. Could you have picked 5 here? Yes. Then you would have put 10 here. Then you would have put 5 square root of 3 here. Just like before, it doesn't matter. This is probably your best choice to keep the short leg as small as you can. All right. Now, stand on your 30-degree angle. And we want the trig values for 30 degrees. SOHCAHTOA, go ahead. Standing on the 30. 30 is your reference. Got 'em? What about the other side of the room? Everett, you got 'em? All of them.
For sine, I got 1/2. For cosine, I got square root of 3 over 2. For tangent, I got square root of 3 over 3. For cosecant, I got 2. For secant, I got 2 square root of 3 over 3. And for cotangent, I got square root of 3.
You are correct.
So, when did you get myself? Yep.
Those are all correct. Okay, and then our last angle we're going to work with is the 60-degree angle. Do I need a new triangle for 60-degree angle? We can use this exact same triangle. We're just going to move our reference point to the 60-degree. Now you're standing here. And then run through them. I'm not going to make you redo these in the homework again. This is going to be it. So go ahead, fill in all 6 of these, and then we're going to be done. It is.
Really?
It is.
You mean
You're just, all you're truly going to practice is that given one side, find the other side stuff.
So geometry.
Yes, geometry.
So today we do geometry.
Yeah.
That's fine with me.
We're gonna come back to this 30, 60, 90, 2 more days of it.
There's a lot of trig like geometry.
They're kind of married together, yes.
See, I hated geometry because I had Mr. Drew, but I looked at stuff.
Ah, just so you know, that's going on YouTube.
Yeah, everything goes on YouTube.
Must be careful.
Hopefully he watches it. I was sitting behind him at a...
But I don't have to give him your name.
He was sitting behind me at the red light the other day.
Usually I record first hour, but now you guys are a day ahead, so you're getting recorded.
No, he was like falling super slow, like way up, like he knew it. And I just took a video.
Wait, what?
You
You should just whip like a McDonald's bag out here.
Well played.
How great that'd be if you had a kite.
Okay, do your 6 ratios so we can wrap this up.
Left towards the rapid, so he had to sit on
Okay,
it.
I'm getting
And I had to
lost.
wait for car to go by.
Getting lost?
S-O-H.
Yep, so,
C-A-H. Opposite.
C-A-H.
Opposite.
and TOA, T-O-A. And you're standing on the 60.
Oh.
That's where you're messing up, that's good you're trying it.
I'm doing S-O-A.
No, we don't want that, there's no S-O-A.
Wow.
SOA, are we good? So what's the sign of 60, anybody? Thank you. Keep going with cosine. And tangent. Okay.
That's as far as I got too, then I stopped.
You can just use the cofunctions. What should tangent? Square root of 3, the cotangent. Very good. Whoever said that. Cosecant. 2 square root of 3 over 3.
How'd you know that?
Secant is 2. And square root of 3 over 3. Okay, so your assignment is not to do these again, because that would be just copying again. There's nothing new you're going to create there.
Is there 4 problems?
Page 71, 59 to 62.
Is that it?
That is it.
Oh my. There is 4 problems. There's 3 problems.
59, 60, 61, 62.
Yeah, and there's 4.
4. Go.
Yeah.
4 problems. I didn't even know.